Aloha and welcome to this screencast on 7 reasons why JavaScript is better than Java and C++, in my humble opinion. I know that's a provocative title. I do actually believe these things, but what I'm hoping to communicate to all of you is the fact that JavaScript is worth learning and using on its own merits, and that by learning to use JavaScript, in fact, your understanding of programming will expand and you will be a better programmer as a result. Okay? A lot of people think, oh, I have to learn JavaScript even though it sucks just because it's the language that exists to create dynamic behavior in a web page. And that's a common misconception, but in fact, in reality, JavaScript is a cool language. So let's check out why. The first reason why JavaScript is better, this is kind of a meta-level reason, is because it really came from more interesting ideas than Java and C++. So if you look at the historical evolution of Java and C++, you can see that they both kind of came from assembler, and assembler was really just a way of manipulating a specific hardware architecture called the von Neumann architecture. That's not the only architecture you can have for computation, but it's the most common one. Okay, so you can think of C++ and Java, their language features are heavily influenced by this notion of, we have registers and, we have random access memory and, we gotta have, get things into the central processing unit and out of it and so on and so forth. On the other hand, JavaScript emerged from ideas in the programming languages Self and Scheme, which themselves came from the languages Smalltalk and Lisp, which themselves came from much more abstract notions about computation, including lambda calculus and this notion of human-computer symbiosis, which was being worked on at Xerox PARC back in the 80s. And so as a result, you're going to see things like functions as first-class objects, which are a natural result of thinking about programs as executable versions of the lambda calculus, as opposed to syntactic sugar over the von Neumann architecture, where the notions of where functions are simply kind of subroutines. They're just pieces of code that you want to cut and paste, but they don't have their own kind of first-class nature. Like they're not a first-class object like a primitive integer or an array or whatever. Okay, so I think that and if your background is simply in these languages that came out of the von Neumann architecture, you will learn a lot and you will broaden your perspective on computation and programming by checking out some of these other languages, of which JavaScript is one. Okay, so second thing, where is it defined that all arrays can only contain one kind of object? I would really like to know this. Okay, this gets accepted as gospel in all these languages like Java and C++, and until you start using a language which says, I don't care, put anything you want in an array, you don't realize that that's really convenient, and it makes your code more concise in a lot of cases and makes expressing, solving problems much easier. Okay, now I will say in defense of the other side that yes, you can get certain kinds of compile time checking from having arrays have only one kind of object in that, but to me sometimes that's throwing the baby out with the bathwater. Okay, really allowing this flexibility in your collections just turns out to make programming simpler and easier and more straightforward in many occasions. Third thing, functions are first class. Okay, this is a huge thing, and Java and C++ have very crufty, complicated, and difficult to use mechanisms for manipulating functions. Okay, and again, it just comes from their past. You can't really blame them for having the genes that they have. All right, but on the other hand, you go to a language like JavaScript or Lisp or Scheme or many others which come out of more enlightened notions about what a programming language could be, and it turns out that you can do all sorts of cool stuff. Okay, so you can assign variables to be functions. You can assign one function to another function. You can create collections of functions. You can return functions as the value of a function, and that enables you to generate functions dynamically at runtime, which is a really nice feature. As part of being able to do that effectively, there is this notion of closure. And you can see an example of this in that last line. I'm not going to go into it here, but the point being that enabling functions to be first-class objects, again, enables you to do things simply, concisely, and actually in a way that's much easier to understand than trying to implement the same thing in a language which has partial or non-existent support for functions in this manner. Next thing I really like, objects are tilde, mostly equivalent to JSON, which is a textual representation for data. This makes it really, JSON isn't exactly the same as JavaScript objects. There's a little bit of difference, but generally you can take a JSON string like this one right here, and you can read it into JavaScript, and all of a sudden you've got a JavaScript object, and there's none of this craziness that you get in Java, for example, where you've got this choice between doing object serialization, which creates this binary format that's completely useless. You can't understand it at all. Or you have to go through this crazy marshalling, demarshalling thing so that you take your Java object and you create this XML version of it and you write that out, and then you got to parse your XML version and blah, blah, blah. It's crazy out there, okay, in the Java world when you look at the way JavaScript does it, which is just so simple that you think, it's easy. Why did they make it so hard? Fifth thing. I'm sorry, I'm not going to lie, but JavaScript, it's just kicking butt out there. Okay, this is a graph that shows the various package managers for the various languages, and the green line is Java, and the other lines are all the other major languages, and there's just really it's not even close. It's not a contest. Okay. So there's a lot more activity in the JavaScript ecosystem than any other language ecosystem. That's like not even arguable. There are JavaScript hardware devices now. You can buy a little board that runs JavaScript as its operating system, and then everything on top of it is built in JavaScript. You can take any area of computer science, from networking to AI to HCI to software engineering, whatever you think of, and there's a visualization. There's a whole lot of stuff in JavaScript, if not JavaScript being the basis for that particular, domain of application. Okay, so knowing JavaScript is not, at this point in time in 2016, it's not really about, oh, I need JavaScript to be effective if I want to be a web app programmer. You need to know JavaScript if you want to be effective in almost any domain of computer science. Why is that? Why is it growing so fast? And I think one of the reasons is because in JavaScript, it's really easy, relatively speaking, to evolve the language. If you think about Java or C++, they have these standards committee, or they have a corporation named Oracle that comes out with a new version of the language once every year or two, and when that happens, there's all sorts of ruckus, and you gotta download a new JVM, or there's this backward compatibility stuff. Okay, it turns out in JavaScript, language evolution is a lot more simple. Yes, there's a standards committee, and yes, a standard version of JavaScript gets released every year or two, just like these other languages. But if you want to experiment with new language features, you don't have to wait around. You can almost always do it in a backward compatible way, due to the fact that JavaScript supports these two notions: transpilation, where you have this thing called Babel, which can take syntax features in a future version of Java and translate them back into an equivalent JavaScript program written with older syntax, so it can run anywhere or be compiled down to run anywhere. Or in the case that all you really want is a method that should operate on a standard object. So let's say you want to define a new method that will operate on JavaScript arrays. Okay, Well, in Java, if you want to do that, you have to wait around. You have to lobby the standards committee, and eventually, maybe they in some future release of Java, they would have this new method that operates, that's built in, that operates on arrays. The definition, the way JavaScript is defined makes it much easier to just load a file, and all of a sudden, the array object can support new methods. Okay, so that's called polyfill, where if you want to use some future version of a standard library, you can load a polyfill which will provide those future versions in the current, in your current system. And generally they have a little switch that says, oh, is this already defined? Because you are using a new version of language, I won't define the polyfill in that case. Last feature, prototype inheritance. This is a tricky one because if you've grown up in the Java/C++ world, you're used to thinking in terms of classical inheritance. It's the 800-pound gorilla, and so when people encounter prototype inheritance for the first time, they're like, oh, this is weird, I don't like it, JavaScript sucks. Okay, why didn't they use classical inheritance? Well, they didn't use classical inheritance because it turns out prototype inheritance is actually better. I'm just going to say it, okay? It's different, so you got to think differently, but in fact, it's just better, okay? And let me give you two. There, you can go on the web and read about it and convince yourself. You should always do that. But here's a couple simple reasons why I think prototype inheritance is better. First thing, more simple. There's a lot of machinery that comes along with classical inheritance. Interfaces, abstract classes, final classes, virtual-based classes, blah, 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 blah. It goes on and on and on. None of that's even necessary once you shift to this different model of how inheritance works. Okay, so that's nice, but maybe not compelling. But here's a more compelling argument for prototype inheritance, and that is that you can evolve the structure of your classes at runtime. Okay, what this means is that your program can start running, and as it encounters the data that it needs to operate upon, it can dynamically evolve the structure of the classes that it has to represent and deal with and manipulate that data. Okay, now that is profound, I think you'll see. Okay, because what's the alternative? The alternative is in Java and C++, where the programmer has to somehow in advance think about the entire range of possibilities for the data and design a single inheritance structure that can somehow accommodate whatever the data turns out to be. Okay, JavaScript provides the programmer with this additional degree of freedom where they are free when they encounter some kind of data at runtime to make some changes to the class, the inheritance hierarchy and the class structure to accommodate that new kind of data. That's really helpful. Okay? So there it is, my 7 ideas. I want to conclude by saying, not saying JavaScript is perfect, not saying Java is perfect, not saying C++ is perfect. All of these languages have their warts, maybe except for one language, which has no warts. But not every language can be Lisp. Talk to you later.